Hello everyone, I hope you all are doing good. So in today's data structure tutorial, we are going to discuss on sorting algorithm and we are going to start with selection sort. So what do we mean by selection sort? If I want to sort my array in ascending order, that is an increasing order, then in selection sort, what we do, we find the minimum element, from the unsorted sub part or sub array and put it in the beginning. So here my array is divided into two parts. One is the subarray, which is sorted, and the remaining subarray, which is unsorted in nature. Okay. So in every iteration of selection sort, the minimum element from the unsorted subarray is picked and then moved to the sorted subarray. I'm going to describe it by using an example. So here I have an array of 5 items, 10, 9, 100, 20, and 29. And this array is of course not sorted. We can clearly see that. Now how to perform the selection sort, I'm going to take my first element in the first iteration, that is 10, and going to check the remaining subarray. So let me just put a highlighter for the subarray. And what we have to do, we have to find the minimum element out of the subarray, and then this is the first iteration for the first position, and we are going to put the minimum element to the first position. So 9 is less than 10. So currently the minimum element is at 9. Then I'm going to move to the next element, 100 not less than 9, 20 also not less than 9, 29 also not less than 9. So the minimum element is 9. So what we have to do, we are going to put it at the first position and the 10 will come to the second position. So we are going to perform this operation through swapping. Okay, so the first iteration we are good. Now I'm going to move to second position. So for second position, this is my 9, right? Now 10, 100, 20, and 29. So currently this is the array, and I'm going to check for the second iteration, that is the second position. So find the minimum element from the subarray, which is unsorted, from here. 100, not less than 10, even 20 and 29. So there is no element which is less than 10. So we are good with the second iteration. Moving on to the third iteration, that is 9, 10, and 100 for the third position. So I'm just going to put a bar. Left side is already sorted, the right side is unsorted, 20 and 29. So this is also done. Now this is also done. Okay, I'm just highlighting. So in this step, we are going to find the minimum element. So 20 is less than 100, so 20 is my minimum element. Then comparing 20 with the 29, yes, it is less than 29. So the minimum element in the third iteration is 20. So what we are going to do, we are going to do the swapping. So my 20 will come here and 100 will move to the unsorted subarray. So here comes the 20. So the fourth iteration, 9, 10, 20, already sorted. Moving on to 100 and then 29. So now I'm going to check for the fourth position. and 29 is less than 100. So what we are going to do again? We are going to do swapping. So it will come here and this will go here. And then we are reaching the end of the array, that is 100 in the next iteration. And we can clearly see the items are sorted, right? So I'll just brief once again. In selection sort, in every iteration, we find the minimum element from the sub-array part and push it to the beginning. Moving on to hands-on activity. Here I'm going to define a function that would be doing the selection sort. So let's first create an array. So int, going to use the same elements 9, 10, 100, 20, and 29. And after that, I'll just take int n equal to 5. And I'm going to call the selection sort. And after that, I have to print. So I'm going to use the loop, for loop, I less than 5, I plus plus, just access the array by array name and the index. I need to put a new line here. CL, the sorted array. Okay. Now we want to call selection sort. So I'm just going to write the name of the function, and there are two parameters. I have to pass the array and the size of the array. So I'm going to write ARR and the size is 5. Now moving on to the definition of selection sort, I'm going to declare a few variables which I would be using for looping int I, j, and then I'm going to use one more variable which is int minimum index. Okay, so let's start with the first loop. So I have I equal to 0, I less than 4, and I plus plus. So key point to note here is one by one we are moving the boundary of unsorted subarray. Okay, inside this for loop, so this is for the left hand side of the subarray. Now for the right hand side, I'm going to say j equal to I plus 1. J is less than the size, j plus plus. Okay, so here I have put I less than size of array minus 1. Why? Because then I'm doing j equal to I plus 1. So if I'm just doing I is less than 5, I will reach to 4 and j I plus 1 will be 5. So we don't have any indexing at 5. We have from 0, 1, 2, 3, 4. So 5 is not the valid memory that we are going to access. That is the reason our outside loop is size minus 1. Okay, we are good till here. Now here what I'm going to do, I'm going to put my minimum index as I. Okay, the left subarray, I'm taking that this is a minimum element as of now. And then I'm going to find out the minimum element at the right hand side. So here, if my array j is less than the element at minimum index, okay, at that time what will happen? We should update the minimum index. It will become j. So once we find the minimum index, we have to swap it with the element at I. That is the first element. So what I'm going to do now is, after finding the minimum element at the right subarray, which is unsorted, then only we are going to put it at the beginning. So the swapping will happen after finding the minimum element at the right subarray. So let's run the program. Yeah, the sorted array is 9, 10, 20, 29, and 100. Moving on to the time and space complexity. Here we can see we are using two loops. So the time complexity would result to order of n squared, because we are traversing the array, right? Twice. So time complexity is going to be order of n squared. Moving on to space complexity, we're not using any extra space to perform this sorting. So it is in place sorting, the same array elements of size 5. We are reshuffling these elements to finally get the sorted array. So the space complexity is constant, and we already discussed in the previous videos that if it is so, then we define it as order of 1. I hope you are comfortable with the selection sort, and I'm going to provide the GitHub link for this in the description section. If there is anything else you want me to cover related to selection sort, please put in the comment sections. I hope you like this video. Thank you. Have a good time.